Good evening, everyone. So today we shall start our discussion on new set of problem of thickness of the beds. So the thickness of this beds problem are very useful for problem, especially during the excavation. So there will be excavation being done for your dams and reservoirs or sites, wherein the reservoirs and the tunnels. So problems which will be very useful in during your excavation, especially for your dams, tunnels, or reservoirs. During the excavation for the dams, reservoirs, or tunnels, you will be knowing only the upper surface or the upper part of the surface. But the lower part or the lower surface of the rock will always be hidden inside the ground. So you'll not be able to deduce the exact amount of thickness which is required for the rock type and which is required for the excavation. So during which, if you deduce this type of problems, you'll be able to come to a conclusion at what the depth of the rock type is being present, what is the amount of thickness of the rock, and what amount of excavation should be done, especially during your reservoir and tunneling process, because we cannot simply remove the rock type without knowing its exact thickness. So this problem helps in understanding the exact thickness of the rock both in terms of vertical and true forms. Let us take an example of one problem. So you can see here, there is on a horizontal ground, you can see a bed of limestone dips 25 degrees eastwards and measures a width of 160 meters. Find its true thickness and vertical thickness. So this is the problem that is being given. So you can see what is the data that is being given. So the dip of the rock type is being given, that is 25 degrees eastwards. The width of the rock type is 160 meters. You have to find out the vertical thickness and the true thickness. Now let us see what is vertical thickness and what is a true thickness. So the distance between the two planes or two rock surfaces is called as a true thickness. That is, there are usually two planes on a rock. One is upper bedding plane and another one is a lower bedding plane. So the upper bedding plane is a plane or the rock surface which is usually exposed on the ground. The lower bedding plane is the one which is usually hidden inside or interior into the ground. So this lower bedding plane will always be hidden in the inside of the earth surface. So the distance between the distance that runs perpendicular from the surface to the lower bedding plane is usually called as a vertical thickness, and the distance between two planes, that is upper bedding plane and the lower bedding plane, is usually called as a true thickness. So this becomes the vertical thickness and this becomes the true thickness. So the upper bedding plane is usually the one that is being visualized on the surface. The lower bedding plane is the one which is usually hidden in the interior part of the earth surface. Now how to solve this problem? So usually the width is given as 160 meters. So usually 160 meters cannot be drawn on the paper. So we are going to convert them into scale. Respective scale of 1 centimeter equals 40 meters. So 4 centimeters equals your 160 meters. So I draw a line from north south and east west trending line, and exactly at the point of center you measure 25 degrees eastwards this way and then draw a line. So usually the line drawn will be the upper bedding plane. So this is the surface which is usually visualized on the outside of the earth. This will be the visualized part on the which can be seen on the surface of the earth. So we have to find out the lower bedding plane. So what we are going to do is, so this is your upper bedding plane. So you cannot draw anything about this because this itself is your upper surface. So you have to draw beyond this. So from here, measure 4 centimeters and draw a line which is parallel to this upper bedding plane. Using a set square, you can draw a line which is exactly parallel, which runs parallel to this upper bedding plane. So I draw a line, then measure this distance exactly from this point to the bottommost point of the lower bedding plane where the 2 point meets perpendicularly. So measure this distance, you get the vertical thickness, and measure this distance between two bedding planes, you get the true thickness. So in this problem, so we have got when we measured the vertical thickness is about 1.7 centimeters. So you convert them into scale because you have to give the answer in meters. So you have to convert them into scale. So 1.7 centimeters into 40 meters gives you 68 meters, and true thickness is 1.6 centimeters into 40 meters is equal to 64 meters. So in this problem, the vertical thickness is 68 meters and the true thickness is 64 meters. So the distance between two bedding planes is usually the true thickness of the rock type is 64 meters, and vertically it is extending 68 meters beyond the ground. So this sort of problem is very useful in solving the excavation works, especially during your excavation for your tunnels and dams and reservoirs. So during the foundation, you cannot simply excavate the rock and how and how, whenever we want, how much we want. So there should be a particular amount of the rock type that should be excavated, because during your excavation, the rocks itself will be used as foundation material for your dams and reservoirs, and also for your tunnels also, which will be usually you protected as a barrier for your tunnels. So if you excavate the whole rock, then you cannot exactly keep them intact. So that's why what they say is you have to excavate them using this. No, by knowing the thickness of the rock types, it becomes easy for your excavation process. So there are two different types of problems. One is a horizontal ground, another one is a sloping ground. So during which in a sloping ground, what happens is similarly as your horizontal ground itself, but your upper bedding plane and lower bedding plane. Upper bedding plane comes in your normal ground surface itself, but the lower bedding plane usually comes on the sloping ground. Both the slope and the dip will be in opposite directions, using which we are going to see the problems.